Okay, so what if I told you that inside a device that's smaller than your thumb, we could place a working, living model of your heart, or your brain, or even your kidneys?
I know, it sounds like something straight out of science fiction, right? Can we really shrink all the complexity of a human organ down onto a microchip? Well, incredibly, the answer is yes. And this amazing piece of technology is set to completely transform medicine as we know it, not just here on Earth, but for our future missions out among the stars.
So let's dive in. What exactly is this tiny universe? And how in the world does it work?
The best way to think about it is like a miniature biological replica. And I mean, this isn't just a computer model, it's a living, breathing system. Engineers microfabricate these tiny channels that act like blood vessels and little chambers that act like air sacs. Then they add living cells, and the whole thing just comes to life. It mimics everything in a shockingly realistic way, from the actual rhythmic beating of a heart chip to the gas exchange happening in a lung chip. It's wild.
And this technology is already way more mature than you might think. Scientists have successfully created chips for a ton of our most vital organs the heart, lungs, liver, you name it. Each one is a tiny, functional avatar of the real thing. This all sounds incredible, but how are these tiny organs actually built and, more importantly, connected?
It's a fascinating three-step process to create what's basically your virtual twin. First, engineers build a chip that mimics an organ's basic structure. But second, and this is the real game changer, they infuse that chip with your unique living cells. This is what makes the chip so powerful. It's not just a model of an organ, it becomes a personalized model of your organ. And here's where it gets even more amazing. We can go from a single organ to a whole system. As one researcher put it, it's just like using Lego blocks. You can take a heart chip, a liver chip, and a kidney chip and literally connect them, creating this interconnected model of a human body. It's a really elegant, modular approach to replicating our own biology. So, okay, we can build it, but what's it for? I mean, why do we need a tiny Lego version of ourselves in the first place? Well, to understand why, let's just look at other complex systems. You would never, ever test a critical software update on a live power plant. You test it on a digital twin first. You would never let a new pilot train in a real jumbo jet. They spend hundreds of hours in a flight simulator. We use simulators to test things safely and avoid catastrophic failure. Which brings us to this huge kind of glaring question. When it comes to medicine, we test new drugs on animals or in petri dishes, which we know are imperfect models. And then we jump right to testing them on the most complex, high-stakes system imaginable, us. Why don't we have a simulator for the human body?
Well, now we do. This is it. This is the ultimate application. An organ on a chip is a true biological simulator. We can test a new drug on your virtual twin and see exactly how your body will react. Will it be effective, or will it have harmful side effects? We can find out all of that before you ever take a single pill. This technology is already set to revolutionize medicine here on Earth, but its first, most extreme test is happening hundreds of thousands of miles away from home. That's right. When NASA's Artemis astronauts launch toward the moon, they are not going alone. Tucked away in their spacecraft will be a whole collection of these chips, each one a personalized biological model of the astronauts themselves. They are, for all intents and purposes, the tiniest astronauts in history. So why are they doing this? It's to answer some of the biggest questions we have about long-duration space flight. I mean, what does deep space actually do to a human body? We can use these chips to study the brutal effects of microgravity, the constant bombardment of high-frequency radiation, and see how it impacts everything from our DNA and how our cells age to bone density and muscle loss. And here's the genius of the whole experiment. When the astronauts get back, scientists are going to have two parallel sets of data, the actual biological changes in the astronauts and the changes that occurred in their little chip-based twins. By comparing them, they can see exactly how accurately the models predicted the effects of space, and then use that data to make them even better. So this mission is so much more than just a validation test. It's a critical step toward the future of human health, both in space and right here at home for all of us. This whole journey to precision health has really been building for years. This is not the first time these chips have flown. Early versions were tested up on the International Space Station. Now Artemis is providing the ultimate validation, and the data is going to be essential for planning those future long-haul missions to Mars. You know, a 6-month trip each way. But the ultimate destination for this technology isn't another planet. It's right here. This right here is the end game. Precision medicine. An era where treatment is no longer one size fits all. Imagine your doctor taking a small sample of your cells, creating your personal body on a chip, and then testing a dozen different cancer treatments to see which one will be the most effective for you specifically. That is the future this technology makes possible.
Ultimately, the same exact technology that's going to protect astronauts on their journey to Mars is coming back to revolutionize our health here on Earth. And that just leaves us with this one final incredible thought. If we can simulate a trip to Mars, what's to stop us from one day simulating, and maybe even predicting, the entire future of our own health?